we have Ethernet now, and everybody else will have in about 3-4 years. By late 70s, the world had changed. When I started working in 1969, the ICs were just being announced. You could buy AND gates, flip-flops, OR gates, and that was about it. Then they had NOR gates available after a while, and then they had this fancier flip-flops available. Then they had 4-bit registers available. I started SSI, small cell integration. They were just going from transistors to simple gates, and I learned to do the logic design using that. And of course, through 70s, the chips became better and better. By late 70s, the people who were coming out of school, they couldn't design stuff using flip-flops and gates and OR gates anymore. They had to have a chip. If you want to do a serial I/O, they have to be a serial I/O chip. Microprocessor, you need a microprocessor chip. People like in my generation were designing from gates and flip-flops. So I was able to do a Ethernet design using this MSI chips at the time, medium speed integration chips, and using some state machines. And I said, stuff works. Then there was somebody else who had Ethernet test bed. If you wanted to prove your stuff was Ethernet, you have to go to them and see if your stuff interoperates with them. And our stuff interoperated with them just like that. So we said, that's what we'll do. We'll supply the boards to everybody. We'll have 3 to 4 years before anybody else does. And so we had our boards out in about 4 to 5 months after that one. And we were out there selling, trying to sell these boards to people, but we didn't have it funded yet. So we had now done a business plan to raise the money from the VCs, and very quickly discovered that, the fact that board works was not an issue. Everybody assumed that you are Indian, your design will work. So that's not a problem. The problem is that can you really sell? Can you really market? Can you really manage? Do you know how to handle money? And those are the attributes that were not established for Indians yet. So even when our stuff was working, we had trouble getting the funding until we sold to first customer. So one customer bought from us, and then one VC says, one customer is good, but if you sell to one more, we'll give you the money. And so we had second customer, and we got the money from a VC. We raised $2 million to do the microwave epsilon back then. And we had 3-4 years of almost freedom. We did about 1 million boards before the chips are available. So if you were doing the network in 81, 82, 83, all this work was done in 81, 82, the sales were started to happen in 83. 83, 84, 85, we were the only game in town. If you had a PC and a VAX machine from digital at the time, micro VAX, or a PDP machine, or any of the super micros with the standard buses, multibus, unibus, BME bus, we were the only game in town. We could connect all of them. See, so our starting point was the Ethernet boards. But very quickly, you have to have a protocols, the software to do with it. And at that time again, there was a specification announced by Girard's HNS, Girard Network System Protocols, and of course, Digital had a DECnet, and Intel joined these other forces, a protocol called OSI, ISO, OSI protocols, 7-layer model. So, and Apple announced their stuff with Apple Tart, and IBM had the SNA at the time. It was IBM's systems network architecture. And so it was a hodgepodge of things, and there were about half a dozen startups which had adopted XNS by and large. And I started to think through, and we did the Department of Defense had been using TCP/IP protocols. They started to happen in late 70s. There was a predecessor program to TCP/IP, which was didn't have the routing on the bottom, just transmission control, point-to-point transmission control. But I started to think through. I said, the Department of Defense is using these protocols to connect all these machines, the machines that we want to connect on a wide area networks. By and large, nation networking was on the telephone lines. So why don't I put TCP/IP on Ethernet, and I'll have instant solution. And TCP/IP at the time only had Telnet and FTP. It didn't have any of the other things. All these other things happened there. FTP was file transfer protocol, and Telnet was the terminal emulation protocol. So you could use your PC to log into your batches or into your mainframes, or you could do file transfers. And so I said, it's a very obvious solution. I have Ethernet, and if I put the TCP/IP on top of that, but it was very controversial because the TCP/IP was seen as a slow and stodgy protocols designed for error-prone networks. And here Ethernet is a very streamlined, high-speed network. So they were seen as a mismatched. So somebody, and she eventually was the CTO here at Cisco, Judy Aston. I don't know if anybody remembers Judy Aston. Judy Aston had another startup called Bridge Communications, which was competing with us. And she told me brain dead. She says, how can you put TCP/IP, which are slow, stodgy, non-commercial defense protocols on a highly high-speed, high-performance Ethernet? It's like putting a horse in front of an automobile. And of course, my argument was, hey, you have instant solution, and all this error recovery stuff that you have in the TCP/IP probably won't be invoked if there are no errors on the underlying transmission, so probably won't slow you down. And that turned out to be the case. The TCP/IP were just as fast as any other protocols on Ethernet. And of course, and then I came up with the theory that TCP/IP would be a eventual winner. And everybody thought, this is now about 84, 85. But I argued that TCP/IP will be a protocol which is vendor independent, is very robust, is already been proven, is evolving very naturally under the real use. All these other protocols have been defined in the labs. They will not be robust. And and my other theory was, by the time the others are ready, the TCP/IP will already been established. We had sold 1 billion boards ourselves, and chips were about to happen, and they were the only working protocols. By 86, 87, it was very clear that TCP/IP would win. So I'll tell you a story about Cisco. So Cisco started, if I remember right, in 86 or 87. The husband and wife team from Stanford, they were doing the networking inside Stanford. Cisco and Sun were two startups which happened from Stanford. Stanford had their own lab. They had designed the workstation. Those guys left to do the Sun, and they had their own networking team inside, and that team left to start Cisco. So they were looking for funding. We went public in 87 February. 87 February we had done public, and it was very fantastic IPO. And Cisco guys were looking for money, and I wanted to buy 25% of Cisco, and I came and did the deal with the founders. That we did them $10 million for 25% of the company, and I was very happy. But my board vetoed me. I went back to the board. The board said, no. We are not investors. I said, no. This is a very good investment for us because we need to have this wide-area networking. But it was vetoed in early '88, and rest is history, right? Cisco went public in '89, and